Shrek rode on the shoulders of a giant cookie to get past a tall wall and win his love. Shrek 2, obviously. You've eaten too many cookies to get this kind of cooperation, and so you build a catapult to launch yourself over the wall as shown in the figure, and it's a good thing that you're an ogre and can survive the landing. This is a classic projectile problem, but with a little bit of a twist. And the twist is located here in these 15 meters. If you've jumped well, you will not include the top of the wall as a part of your trajectory. You will in fact pass well above the wall. For that reason, we will not be including the y of 15 meters in any of our stipulations for what happens to you as a projectile as you go over the wall. Heading on to what we're actually asked, the first question is, what is the maximum height that you reach? Well, height is the variable y, and so asking a question about height is this, how high? However, that's an ill-formed question. In order to make it a well-formed question, we need to define the condition under which we wish to calculate the variable y. Now, on the way up, your v sub y is positive. On the way down, your v sub y is negative, and so at the highest point of the trajectory, v sub y will be 0. This equation then indicates that the method of solution will be to calculate y under the condition vy equals 0, and that uses the third equation, which is vy squared is v0y squared minus twice g times y minus y0. As in all projectile problems, there are no x's in the y equations and there are no y's in the x equations. However, also, there is no v0 in either equation. When we're dealing with projectiles, in the y direction we need v0y, and in the x direction we need v0x. And the initial velocity is in fact defined as 25 meters per second. That's neither the x nor the y component. To determine these two components, we'll need to break the 25 meters per second into parts, one of them along the horizontal, and we continue horizontal until finishing the triangle is done via the vertical, with a 60-degree angle in that corner. Thus we see that the vertical component, v0y, is the side opposite to the 60 degrees, so that v0y is 25 sine 60, and v0x is the component that is adjacent to the 60 degrees, so that v0x is 25 cos 60. Going back to the question at hand, we need to plug in vy equals 0, and then solve for y. So that we have 0 squared is 25 sine 60 quantity squared minus twice g is 19.6, and y minus the initial height of 0. The only unknown in this equation is y, and so we find an expression that y is equal to the initial velocity squared over 19.6, which gives us the result of 23.92 meters. So far so good. If your maximum height wasn't greater than 15, there's no way you're making this jump over the wall. However, this doesn't really prove that we make it over the wall. We have to continue to calculate. Part B asks us to calculate, when do you pass over the wall? When is a question which is answered by supplying a value for time. However, when is an ill-formed question. We need to make it into a well-formed question. Looking back at the original diagram, we see that passing over the wall should not be defined as y equals 15. That would mean that your trajectory touches the wall. Hopefully you clear the wall pretty well. When you pass over the wall is when your x location is 40. This is solved using the xt relation, which is written as x is x0 plus v0x times t. Remember, the acceleration in the x direction is 0. The only unknown in this expression will be t when we plug in the numbers, so that we can solve for the time as t equals 40 meters over the x component of initial velocity, which is 25 cos 60, yielding 3.2 seconds. Part C asks us to calculate your height as you pass over the wall. Height is the variable y, and we'll answer this question by expressing a numerical value for the variable y. Now the question is, how do we specify that you pass over the wall? One way you might imagine is to say that passing over the wall means the point on the trajectory where your x is 40, that places you directly over the wall. However, this asks for a calculation on y under condition on x, and there are no x's in the y equations and no y's in the x equations. In fact, the only variable found in both sets of equations is time, and so this could be solved as a two-part question. First, when is your x position 40? And then second, what is the y at that time? As it turns out, in part B of this problem, we've already solved for when your x is 40, and that answer was a t of 3.2 seconds. Thus, to calculate the solution to the problem at hand, we need to find the y under the condition that t is 3.2 seconds. This will involve consulting the yt equation, which is y is y0 plus v0 yt minus 1/2 gt squared, and evaluating all of this when t is 3.2 seconds yields y is 0 plus 25 sine 60 times 3.2 minus half of g is 4.9 times 3.2 squared, which yields the result 19.1 meters. Congratulations, you cleared the wall. Finally, we need to calculate the magnitude of the velocity as you sail over the wall. Well, magnitude of any vector quantity is calculated by finding the square root of the x component of that quantity squared and adding the y component of that same quantity squared. This question is still ill-formed because Vx isn't a constant and Vy isn't a constant. What we need to do is we need to specify how to determine which Vx and which Vy, and the answer is to make sure it is at the moment while we sail over the wall. Now there are two ways currently to specify that moment. One of them is that sailing over the wall is at x equals 40. That sounds like a quite reasonable approach for v sub x. Another one is at t equals 3.2 seconds. And finally, it's when y is 19.1 meters. To get v sub y, we can either use vy when t equals 3.2, or we can use vy when y is equal to 19.1. I think we'll use t is 3.2. Now the first of the two issues in this problem, what is Vx when x equals 40, is easier to solve for than you might think. Because Vx is a constant, Vx at any moment is equal to the same as its initial value, which is 25 cos 60, or 12.5 meter per second. Vy, on the other hand, is going to take a small calculation to find out Vy under the condition of t is 3.2. We will turn to the Vyt equation, which is written as Vy equals V0y minus gt. Plugging in a time of 3.2, we get the result Vy is 25 sine 60 minus g times 3.2, yielding the result negative 9.7 meters per second. Plugging both the Vx at the moment in question and the Vy into the square root expression will yield us the final answer that the magnitude of the velocity at this moment is equal to 15.8 meter per second. You'll be going even faster than this when you hit the ground, and so once again, it's a good thing you're an ogre.